Hello everyone, my name is Vijay and I hope you must be learning mathematics concepts, especially in this chapter, matrices chapter, properly by following the previous videos which we have uploaded on our ACS 4 channel. I think in mathematics we have uploaded 4 videos on this chapter. You must have seen those videos and must be getting the things also. Keep sending your doubts. One thing I strongly recommend that please write all those concepts, examples shown in that videos or given in your NCERT book. Please solve those examples, because to have a proper understanding of the concept, it is very important that you write, because mathematics or any other subject can't be learned by simply watching online or offline videos. Please solve and write, and I hope then certainly you will get the things. In this video also we will discuss some more questions. In previous videos we have done the things up to the last concept, which was elementary transformations and inverse of a matrix. Now let us solve some more questions on miscellaneous exercise in this NCERT book. Let us see the first question of this NCERT. This says that let A is equal to a certain matrix which is 0, 1, 0, 0, and then show that AI plus BA raised to power n is equal to A power ni plus n A to power n minus 1 BA, and is true for all n belongs to n. So this part we have to show that this statement is true for all natural numbers. So when we have to prove something, some statement involving natural number, and we have to prove for all the natural numbers, we have a method. What's that? Principle of mathematical induction we are going to use. So let us assign this statement certain name, Pn, assumption n, and let us check that P1 is true or not. So if you know, for mathematical induction, we first show for that it is true for n equal to 1. We assume that it is true for certain n equal to k natural number bigger than 1, and then we prove that it is true even for its successor also. Then it becomes proof for all natural numbers. So let us see, for n equal to 1, LHS will be, you put in left side n equal to 1, and it will be AI plus BA power n. As it is, it will become, not writing again, right hand side will become A power 1 I plus 1 A 0 B A, and if I simplify, it will become AI plus B A, which is same as left side, and this means that the P1 is true. Right, now let us assume Pn is true for some n equal to k bigger than 1. For 1 we have already proved. That is, let's replace n by k, and then it will be AI plus BA to power k is equal to A to power k I plus k A to power k minus 1 BA. Let it be equation 1. Now to show that this statement Pn is true for n equal to k plus 1 also. That is, now let us write what we have to show by putting n equal to k plus 1. So it will be AI plus BA raised to power k plus 1. This replacing n by k plus 1 here becomes equal to A power k I plus k 8 power k minus 1 b sorry, this will be k plus 1 I, and it will be k plus 1 a to power k b a. We have to prove it. Now let us begin with LHS left side, and I can split this entire term in two factors up to power k and into ai plus ba, right? Why we have split it? Because I have been given ai plus ba raised to power k value in equation number 1. So let us pick this value. This is equal to, let's put the right hand side value, this value, plus k a to power k minus 1 ba multiplied with ai plus ba. Now let us multiply. These are matrices. Keep remember one thing, that these are constants. A, the small ones are constant, k is constant, capital A and capital I is a matrix. So constant multiplied with matrix means scalar multiplication it is, and we have a habit of writing the constants means real numbers in front. So let's open both the brackets, 2 terms here, 2 terms here. If we multiply, 4 terms will generate, and I am going to write the constants in front. So a to power k I gets multiplied with this term, so what will generate? A into a to power k becomes a to power k plus 1, I with I becomes I square. In next step I am going to write it I, right? Plus a to power k into b, I'll write first, plus I into a, right? Of course IA will also become a, should not be written as AI, right? Because if we are I is in left, it should not be written in right automatically. It may become equal in certain cases, but not always. So, and this term k a to power k b ai plus k a to power k minus 1 b square a square, right? This becomes a to power k plus 1 I plus a to power k b I a is a plus k a to power k b ai is a, and plus this certain term as it is I am copying. Now if you see what we have to bring, we want to bring this thing. So this already has come. This term, if you see a to power k b a can be taken common, right? Let us take common, and if I take common this as it is, so what will remain? Here nothing, so 1 plus here k will remain. Now this term as it is I am copying here, and we want to bring up to here only. So this is purely undesired term. Now this a value is given and we have not yet used. Let us make use of it. Let us find a square. A square means a into a, which means 0 1 0 0 0 1 0 0, and if I multiply, let us see, 0 0 0 0, 0 matrix will come. So this term becomes 0. So what remains is nothing but the right hand side and hence it is true for all natural numbers. This can be written, right? Thank you for completing this question, and certain more questions must be solved of this variety. Even in textbook also, I think question number 2 and 3 are given on this. Question number 2 says that if A is equal to matrix 3 cross 3, and prove that A raised to power n is equal to another matrix involving natural number. So this too can be done. with the help of principle of mathematical induction, quite on the same pattern as first question. Third question is also based on, because natural number n is involved, we have to prove for all positive integer is written, that is same as natural number. So this also must be solved on the same pattern by using principle of mathematical induction. Now let us see the next fourth question, which says, if A and B are symmetric matrices, then prove that AB minus BA is also is a skew symmetric matrix. So here we have been given, let us write given and what we have to show. Here it is given that A and B are symmetric. Means what? Symmetric means what? Symmetric means, as per the definition, that its transpose is equal to A and B is also symmetric, so its transpose is equal to B. Alright? Then what we have to show? We have to show AB minus BA is skew symmetric. Okay, let us try to prove it. To prove a certain matrix skew symmetric, what we need to do? If you remember, the definition of skew symmetricity says that X is skew if X transpose is equal to minus X. So if we want to check the skew symmetricity of AB minus BA, let us find its whole transpose. AB minus BA, let us find its transpose. And if you remember the property of transpose, which says by using that, this will become AB transpose minus BA transpose, isn't my property? And again, there is a property of transpose for product of matrices. It becomes B transpose into A transpose, and this becomes in reverse order A transpose B transpose. Let us make use of the given statement that A transpose is equal to A and B transpose is equal to B. So this becomes BA minus AB. This can be written as a scalar multiplication with minus 1 multiplied with AB minus BA. And now here it is the pattern, X dash is equal to minus X, means X is skew symmetric. So this means that AB minus BA is skew symmetric. Right. So this was the easy proof. Let us see the next one, fifth question. Question 5 says that show that the matrix B dash AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. So A is given. So two cases are there, that if it is symmetric, then so and so to be proved. So actually there are two parts, right? First part is, let's write given and to show statement properly. Given and to show. Given and to show statement लिखने से हमारी क्वेश्चन के प्रति जो वो एक अंडरस्टैंडिंग होती है एकदम क्लियर हो जाती है, right? Otherwise sometimes we make mistake. We sometimes use opposite. So given is that A is symmetric. Of course, means A transpose is equal to A, and we have to show that B dash AB is symmetric. Again, the same concept, that if we want to prove certain matrix symmetric, let's take its whole transpose. Let's take its whole transpose. And if you remember the property of transpose, the property says that XY whole transpose is equal to Y transpose X transpose. and this property is true even for product of three matrices also, right? It becomes equal to the multiplication of their respective transposes, but in reversed order. So let's take the reversed order. It becomes B dash, A dash, and B dash to whole dash, which becomes B dash, A dash, and double dash means B itself, right? There's a property that B the dash to dash will be B itself, right? Anything given? Yes. A dash is same as A. That's right. A dash is replaced by A. And here we can see that B dash AB whole transpose is same as B dash AB. That concludes clearly B dash AB is symmetric. Easy though. But not yet done, because in the question it is very clearly written that prove that B dash AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. So one part already, this we have done. Now one more part is to be done. Here what will be the given statement? That A is skew symmetric, which will mean that A transpose is equal to minus A. And what to show now? We have to show that B dash AB is also skew symmetric, right? Means its whole transpose is to be taken and is equal to minus of itself is to be proved. This I am leaving for the viewers. Quite very similarly it can be done. Now let us see the next question. Let us see question number 6. Let us see the hints. They are saying find the value of x, y, and z if A satisfies the equation A dash A is equal to I. So A here it is given 0, 2y, z, x, y minus z, and x minus y, z. Then and A dash A is equal to I given. Then we have to find x, y, z values. Okay, let us make use of this statement. A transpose is equal to into A is equal to I. Let us begin with this given statement and let us put the values. A transpose, let us interchange with rows and columns multiplied with A as it is equal to identity. Identity means 1, 1, 1, 0, 0, 0, 0, 0, 0. X as it is 0, 2y, z, x, y minus z, x minus y, z. Transpose 0, 2y, z, x, y minus z, x minus y, z. Let's multiply. This is 3 cross 3. This is 3 cross 3. If we multiply, yes, we can multiply. Final order will be 3 cross 3. That's right. And this will be 0 x x 0 x x x square plus x square 2x square it will be 0 0 xy minus xy 0 it is 0 x minus xz plus xz 0 it is. Good. 2y 0 yx minus yx 0 2y 4y square plus y square plus y square 4y square plus y square plus y square 6y square 2yz minus yz minus yz 0 it is z square plus z square z square plus z square plus z square 3z square it is. Then z square error, this term will appear here. First term will be 0 minus zx plus zx 0 and this term will be 2yz minus yz minus yz 0. is equal to identity. Very nice matrix here we have got. Now we know well that when two matrices are equal, that each and every entry is same actually. So let's compare, and here we get directly 2x square is equal to 1. What does it finally conclude? X square equal to 1 upon 2 and x equal to, right, that's right, can we write directly? X equal to plus minus 1 upon root 2. Y is equal to plus minus 1 upon root 6, and z equal to plus minus 1 upon root 3. Simple. Question number 7, let us take the hints only. Seventh question says that for what value of x will this equation get satisfied? 1, 2, 1, and this is 1 cross 3 matrix. It is multiplied with 1, 2, 0, 2, 0, 1, 1, 0, 2, and this is multiplied with a column matrix 0, 2, x, and this entire thing is equal to 0. This is 3 cross 3 and this is 3 cross 1 matrix. So you should understand that you cannot change the position of matrices, right? No commutativity in matrices multiplication, so I cannot club with any other thing this matrix. I have to keep the things as it is, right? So you can start multiplying either this 2 or this 2 in any manner. So let us begin from anywhere. 1 cross 3 and 3 cross 3, when gets multiplied, the final order becomes 1 cross 3. So if I multiply this and this matrix, 1 cross 3 matrix will come. We'll write this as it is, will write, and equal to a 0 matrix. So let us multiply 1 to 1, 1 to 1. It becomes, let me write in rough, 1 plus 4 plus 1, how much? 6. 1 to 1, 2, double 0. 2 plus 0 plus 0 becomes 2. 1 to 1 gets multiplied with 0, 1, 2. 0 plus 2 plus 2. 4 it is, right? And this becomes 1 cross 3 and 3 cross 1 matrix. When they get multiplied, the final order will be 1 cross 1. Only one entry will come, right? And that will be how much? 6 into 0 is 0, plus 2 into 2 is 4, plus 4x, and is equal to 0. Directly it can be equated and it will be x equal to minus 1. Easy, right? Let us see question number 8. Question number 8 says that let A is equal to a matrix of 2 cross 2 order, 3, 1, minus 1 and 2, and to show that A square minus 5A plus 7I equal to 0. Easy it is, hence only I am leaving. A square you can find by doing A into A, and the usual manner you can multiply both matrices and you get A square, and then after you can begin with left side and you can just put the values of all. A square minus 5A plus 7I, and no doubt it will become 0, certainly. So easy it is, please try. Question number 9th is quite similar like 7th. It can be done in the similar manner. Question number 10th also I am leaving for viewers. Question number 11th, let us see. Question number 11th says that find a certain matrix X which satisfies this equation, that X into this matrix, and this is equal to another matrix of order 2 cross 3. So first let us guess, and we have to find out the matrix X. So first let us guess the order of X. If you see that matrix multiplication will be possible only, this is same as the number of columns here. So this must be 2. X must have 2 columns, right? Because this and this must be same, otherwise matrix multiplication won't exist. Now the final matrix, resultant matrix, that order, this thing comes from here, and this 2 from this position it comes. So this must be 2. So capital X matrix should have an order of 2 cross 2. So let us assume a 2 cross 2 order matrix, anything, any variable you can use, and substitute here and multiply and equate with the right side. Give a multiplication, 2 cross 2 and 2 cross 3. Finally 2 cross 3 order matrix will generate. So this is A plus 4B, this is 2A plus 5B, this will be 3A plus 6B, this is C plus 4D, this is 2C plus 5D, and this is 3C plus 6D, and is equal to the same 7 minus 8 minus 9, 2, 4, 6. Equate and you will get multiple equations. So if we equate, we will get A plus 4B is equal to 7, 2A plus 5B is equal to minus 8. Can we solve them? We can give a multiply of 2 and we can give a subtraction. This term will get deleted and this will be 8B minus 5B, 3B, yeah, subtracting, and this will be 14 plus 8, how much? 22. I'm weak in calculation many times, please check it that it is right. Yeah, and I think this much hint is enough, right? Similarly, you can compare some more equations. C plus 4D is equal to 2, 2C plus 5D is equal to 4, and the value can be obtained. Nothing more in this question. Question number 12, let us see. Question 12 says that find A and B if A and B are square matrices of same order such that AB equal to B. And let me write given statement properly. The given that AB is equal to BA and A and B are square matrices of same order, then show that A B power n is equal to B power n A. To show A into B to power n is equal to B to power n into A is true for all natural numbers. Again, that we have to show that it is true for all natural numbers. After that, one more thing they are asking about, that we will discuss later. To prove this, we have to show that it is true for all natural numbers. So what principle we have to use? We have to use principle of mathematical induction. So we shall try to prove it by the principle of mathematical induction. For that, let us give this statement some name. Let it be assumption n. Let us check it for n equal to 1. So left side will be AB and right side is BA, but already we have been given that AB is equal to BA, so LH is equal to RHS, right, using given statement. So it is true for n equal to 1, so P1 stands true. Now let us assume that it is true for some n equal to k. Assuming pk is true, for n equal to k bigger than 1. So simply replace n with k, and this becomes AB to power k is equal to B to power k into A. then let us show that it is true for n equal to k plus 1 also. That is to show, just replace k with k plus 1. A b k plus 1 is equal to b k plus 1 into a. So how to begin? Begin with LHS. And make use of the information that we have. Let us give this information as equation 1. If I write it as a b to power k into b, we can write, there is no issue. And a into b to power k, we have assumed from equation 1 that it is the same as b to power k into a. B to power k into a, we have written into b as it is, we have written using equation 1. And we have to bring this thing. Let us use associativity of product of matrices, and this we can write b to power k into ab, and ab is given equal to ba. Let us write ab, let us replace with ba. Again use associativity, let's club these two, and this becomes b to power k plus 1 into a, and which shows that the statement is true for even k plus 1, and hence the statement is true for all natural numbers n. Right? So one part of this question 12 gets proved here. One more part they are asking that further prove that AB whole to power n is same as A to power n, B to power n. This I am leaving for readers, for viewers. Please try this part. Here also whole power n you have to prove for all natural numbers. So whenever you have to prove for all natural numbers, the method is principle of mathematical induction. So in the similar manner, please try the other part also. Let us see some more questions of this exercise. Question 13th says, multiple choice question it is, that it says that if alpha beta is equal to alpha beta gamma minus alpha, and this capital A matrix satisfied A square equal to I, then prove which of the following option is correct. Let us examine what happens when A square we equate with I. So if I multiply, let me write A square first. A into A, simple. Let us multiply alpha square plus beta gamma. Right, first row, first column, first row, second column, alpha beta minus beta alpha becomes 0. Right, gamma alpha minus alpha gamma. Alpha and beta and gamma are here real numbers, not given, but in our syllabus the entries are up to real numbers only. So real numbers commutativity of multiplication I am using. Gamma beta minus plus, this becomes gamma beta plus alpha square. So you can, I think the same thing, same, right? So you can select the correct option, maybe option C perhaps. Question 14 says that if A is both symmetric and skew symmetric, then it should be what? Should be diagonal, should be 0 or square. If a matrix is symmetric and is skew symmetric, both, that A is symmetric symmetric and skew symmetric. Both it is. So if A is symmetric, it means A transpose is equal to A. And if A is skew symmetric, it means A transpose is equal to minus A. And if I equate them both, it becomes A equals to minus A. Twice A becomes 0. So A should be 0 matrix. Question 15th is also not too difficult. It is easy only. A is a square matrix and A square is equal to A. And then you have to find the value of I plus A whole cube minus 7. Whole cube we can expand by our usual algebraic expansion of A plus B whole cube, right? Because 3 brackets will get multiplied, you can think in that way, and directly I can write I cube plus 3I square A plus 3I A square plus A cube minus 7A. Use matrix algebra. Identities, I cube becomes I plus 3I square becomes I becomes A plus 3I into A square becomes A square plus A cube, we can write A square into A minus 7A. Now make use of this statement. A square is same as A, and this A square will in next system become same as A, I plus 6A plus A minus 7A. Finally it becomes same as I. Right, so that's all from the miscellaneous exercise. Some more questions from miscellaneous examples or from other reference books can be tried. Thank you everyone.